programming languages. You love them, you hate them. For many of us, they're tricky little beasts. We love talking about them. I'm Jas here, and if I can misdirect your attention this way, that's Mike. This is a podcast series about programming languages and what's next.
What are we talking about today, Jas?
So, a little bit of misdirection, maybe. What do you think?
Programs that aren't what they seem.
Programs that aren't what they seem. We need an alliteration, Mike. I can't think of a good alliteration to title this podcast. I know what we're going to talk about. We're going to talk about this Trojan Source paper, but I need something catchier than Trojan Source.
Well, I like trivia.
You like trivia?
You know, the focus often with programming languages, we try to keep it on semantics because that's kind of, you know, the most important thing. But actually, syntax sometimes affects of the meaning of programs, and so I thought we might do token trivia time.
Token trivia time it is. Token trivia time.
This is a security engineering paper. It's not a programming languages paper per se. It's all about assuming that code review or code auditing, you know, having a human read over code is part of your process for ensuring, you know, reliability of your software, the security of your software. How could you abuse that? And so it's all about how do we make a program say one thing to a reviewer, but another thing to the compiler. And this Trojan Source paper is about using a particular set of Unicode code points that are often allowed, you know, they're often treated as white space, or they're allowed in identifiers, or they can appear unescaped in strings, using those Unicode code points to affect the meaning of other Unicode code points. So for example, a lot of Semitic languages using the Perso-Arabic writing system are right to left. And so Unicode has control characters that affect the directionality of chunks of text.
Okay.
And so you could say kind of, until I tell you otherwise, treat text as right to left, or until I tell you otherwise, treat it as left to right. And these structures or these particular control characters can kind of nest. And that's where the complexity comes in, right? You can turn something that looks like a comment because it starts with /*, but as far as the, you know, with the, but what you're actually doing is */ maybe you're multiplying something by a regular expression, literal. And you know, there's we should
definitely talk about multiplying things by regular expressions, but maybe later on.
Well, right? You know, so multiplying something by a sub-expression that starts with a regular expression, literal. Which, you know, might actually type as a number. And so there's these tricks that you can use, and so, you know, something looks like a comment. So you might assume that it's not actually code, but then the stuff in there actually does execute as code, and so they outline a number of these tricks.
But this idea of confusing a human code reviewer, this has some history, right? Like we've known about these kinds of problems previously. Why is this paper getting so much attention, you know, in the last couple of weeks?
So yeah, confusing people for fun and profit has a long history, and I think in the obfuscated C world, I mean, you know, you wrote a book.
I definitely did write a book on how to confuse.
So right. maybe I should be telling you this. But yeah, so you know, like obfuscating code for fun, it has a long history in programming language community, and I think, you know, obfuscating code for profit, you know, maybe that's less well known, but yeah, but there are examples prior to this paper that do not use the particular techniques described in this paper.
Like, is the use of Unicode and like bidirectional characters, like, is the reason why this paper is getting traction because the techniques that they describe are so universally applicable to many different languages versus the tricks that have been used before that were very specific to languages? Or is this just like, a better marketing job than like previous cases?
So there's an element of like, oh no, I'm entering the dark web kind of, to the website. And I don't, I'm super petty, but I'm trying not to begrudge the authors, their need to get people to read their paper. And I think one of the things they want to do is they want to try to solve this problem at scale by, so for example, a code review tool on GitHub or Atlassian might, try to bring, this to their attention and to motivate people within industry to actually fix bugs for other people.
Thank you for being petty, Mike, so that I don't have to be, because I'm about as petty. Okay, so if I read the paper right, like the paper hints that this is a compiler problem. What you are saying is subtly different. You're suggesting that there's tools and IDEs and linters and there's
different layers of elements of the ecosystem that could play a part in solutions to this problem and to the larger problem of like unnecessarily obscure code, right?
Right. And I mean, like, don't take Unicode away from me, from my source code. Like, I want to be able to assign an error
poop emoji equals
poop emoji is, maybe if they just made an exception for poop emoji, I think that all the developers all the security people that are like, no, will probably just dial it back and be like, yeah, okay, fine, as long as I can have my poop emoji.
I think, some code is more readable when the poopy places are obvious, right? So, if that's part of your flow.
Even in cases where the source code, I mean, there's a difference between the source code, which you are producing, which produces a program. Even in those cases, you might want your source code, even if you disallow Unicode characters in variable names that allow you to express yourself, you may still want, strings and other characters that you're going to eventually render to the final user to be, to be directly expressible in the language that you're going to be able to produce in the end. So, at the very least, maybe variables, we could make an argument that like, oh, I'm sorry, we're, the history of programming languages has this very Western cultural inheritance to it, but like, the strings that you're producing have to be produced for different languages. And so at least inside strings, at least inside, content that you're going to render to the final user, Unicode characters should be allowed. But like, I think that the point that you're making is a much stronger one, which is not just for the users. Developers are users too. I think that is a phrase that I'm going to reuse repeatedly in this podcast, right? Like, developers are users too, and like, we need to cater to them. And to just take this away because there's this potential for confusion is a dangerous thing to do. And
so
it's a selfish thing to do.
I think yes, and I think the authors Boucher and Anderson, if I recall correctly, if tokens are well balanced as far as kind of directionality encodings and these other, kind of control characters. So if you're going to allow, if you treat control characters as white space, that's probably not, good, because then, they can be imbalanced and things get confusing. But if you allow identifiers, if you allow control characters at the beginning and end of identifiers and the lexer, your parser, rejects as invalid something when a token is not well balanced according to these control characters,
Right.
then you're probably okay. So you might have a string literal that embeds these control characters, but as long as everything starts and ends inside that string, that's okay.
But both by the compiler, but also by humans that are like, I mean, I think that one of the things that like I took away from this paper is the insight that, you know, whenever the compiler is doing something completely correctly, but which is different from human intuition, then you know, inside that difference you can squeeze a whole bunch of
and they talk about
right?
What is it, homoglyphs, you know, characters that look the same but are different according to Unicode. And so when you've got, you know, when your identifiers are, you know, you're comparing identifiers based on string equivalence, you know, lexicographic equivalence, and so abuse of normal forms and use of like the capital letter I and the Roman numeral I, you know, that kind of stuff. You know, those are different Unicode code points, and so, you know, they're different as far as string equality is concerned inside the compiler, but they look the same. So,
you promised me a trivia night? No, a token trivia time.
There's a time for token trivia time.
The alliteration is very important there. Let's do trivia time.
Okay, token trivia time. And so I'm going to show you some examples of code in languages that we all know and love. And, you know, dear listener, don't worry if you can't follow along. We'll kind of, you know, if you don't know all of the languages that we talk about, but we'll try to explain it. Look at some Java code. You know, system.out.println, open parenthesis, and then, you know, // it's a line comment. Cars in Java can look like, and we've got another line comment, /u 000a, and a whole bunch of other sequences like that. And then on the next line, double quotes, ye /u 0073, double quotes. And then, yeah, like a comment, u plus 73 is s in, you know, and then we've got a comment, // strings can contain comment parts like */ unescaped. And then finally, on another line, we close parenthesis, semicolon, right? What do you think this is going to do?
Well, clearly, you know, I might be suspicious of this u plus 73, but I went and looked that up. That's clearly an s. The comment is correct. This clearly was print out yes.
It prints out no.
What are you talking about, Mike?
And so, you know, this is an example of where I guess the kind of overarching theme here is we want to make it very easy for people to write code.
Right.
And you know, when Oak was starting, and when, you know, and later Java.
Wait, what is Oak?
Oak was the precursor language to Java. Java said, the Oak developer said, we're going to allow you to escape characters using /u in strings, but also in identifiers, so that you can use any Unicode code point, any letter, you know, number kind of, you know, identifier part code point in your identifiers. But we're still going to make sure that no matter what your identifiers are, you can convert any Java program to a lower 7-bit ASCII program so that it works consistently in multiple character encodings, not just, you know, when you save it as UTF-8.
So if I remember right, the way that they did this is there is a clean pass that happens early, where they go through and convert all of the Unicode escape characters into a complete character, so that by the time the parser gets to see the code, all of these Unicode escapes have been
Yeah.
have been expanded, which is
Yeah.
maybe an interesting source of the problem, because a human looking at this, is making assumptions about where the escape are going to be. But like, by the time the
Yeah.
compiler sees this, some pieces have been expanded. Does that seem about right?
Yeah, and as the Trojan source paper points out, sometimes humans make, sometimes tools like your pretty printer, your token colorizer, make different assumptions than the compiler, ones that may reinforce your assumption rather than disabusing you of notions, right?
I see.
And so, yeah, in Java, the first step is you fetch a source file, which is bytes, and you convert those bytes to UTF-16 code units, basically Java characters. And then you go over that list of Java characters, and when you see a /u followed by 4 hex, you replace it with that character, unless there's an odd number of backslashes before it, so that, a /u does not get replaced, right?
Right.
And what that means, if the first /u000a, that is a line feed. So that actually ends the comment.
Right.
And then we see /u0022, that's a double quote. And so embedded in that comment, it's not just actually showing you what, it's not a comment showing you what Java escape sequences look like. It's actually a string token that says no, followed by the start of a block comment that then ends at the / at the end, in what looks like the fifth line there looks like it starts as a line comment, but actually starts in a block comment, ends a block comment, and then has a line comment after that.
I do have to say that there was a part of me that was suspicious when it saw the / in the final comment. You're like, why?
Because that's a common trick amongst penetration testers, people who are looking for XSS in web pages, right?
So this is the other part, right? Like I think it was Scott Craver that ran I want to call it Misdirected C. No, it was called the Underhanded C Contest. Whoa, I was going to say 10 years ago. It's probably longer than 10 years ago. Where, the contest was to write source code that would get past the reviewer, a manual human reviewer. And, code like this is code that you would see. And presumably you would rely on what, like, is it the compiler's responsibility? I would assume that the linter or like one of the tools I'm running is like, hey, this like, don't block me, but like this part seems weird, right? Like I have an intuition, but like, aren't these just bugs in the linter? Like, shouldn't we just fix bugs in the linter?
The underlying problem is that syntax, to make it easier to write code, one way to do that is to, you find something, oh, people write some code and they think it means this,
right?
But what it actually means is this. And so according to the principle of least surprise, the language would be better if people's expectations matched reality, right? And how do we make things better? Well, there's a big temptation, just make the lexer or the parser a little more complicated, right? And so, famously, Perl can only be parsed by Perl, right?
Mm-hmm.
Yeah, as readers and writers, we use contextual cues to figure out what things mean. So in this next trivia example, here's some JavaScript. Let I equals 1, comma, j equals 2. And then a page-long comment, a page-long block comment, and why we're doing the below. So imagine, this program is much longer than actually fits on this slide. And so the relationship between the last line and the next is obscured. So what do you think this is going to do?
So
and I should just, for people listening, the next line is /\u0063. And so it you tell me what you see, Jas.
Yeah, so this is assigning 1 to I and 2 to J, and then some kind of complicated explanation, and then what looks like a regular expression that is trying to make sure that it might be testing for some particular browser bug, I guess. And if it's like, oh, it found that kind of browser bug because constructor matches this other case, then it just alerts that regular expression incompatibility exists. So that's what I would assume if I was eyeballing this code.
That's exactly what I wanted you to think.
This is too close to Halloween for that particular laugh. What is going on?
Well, imagine that comment wasn't there and there was no line break. J equals 2 / that now looks like a division, right? And
oh my goodness, yes.
Yeah, as we've already established, allowing Unicode escapes in identifiers is a good way to help people using other character sets, right? And so this is actually J equals 2 / constructor.constructor, a call to constructor.constructor of console.log of 1, which, for the people who happen to be, again, pen tester adjacent, constructor.constructor is the function constructor. We've just created a function with code, essentially doing something like eval and run it. And then the /i.test, which looks like, oh, I'm ending a case insensitive regular expression. I'm actually then dividing,
by the I that you just defined.
Expression. Yeah, but by 1. And then, yeah, I've got a function call that, so I essentially embedded code in the regular expression, and none of this used any of the Trojan source techniques, right? I'm just exploiting oddities in JavaScript syntax, where the JavaScript developers said, we need regular expressions. Regular expressions start with the same character that starts a division operator, right? So we'll use context. A number followed by a /, that's probably division. Whereas a / following a semicolon, that's a regular that's a regular expression, but the semicolon doesn't get it inserted here, and so that ambiguity, that it's not an ambiguity technically, but that ambiguity, the compiler sees it one way and the human,
right, it is a human ambiguity.
It's a mismatch in expectations, right? Yeah.
Right. And the / character is particularly interesting because, as you say, it introduces division, it introduces regular expressions, and it introduces line
comments,
line or block comments. Right. I have a puzzle that I'm going to drop in here, which I'm particularly proud of, which takes advantage of this exact kind of confusion in order to tease out at least 3 different things that a human may think happens. You're completely right. This is not a Unicode problem. This is maybe a syntax level problem. But
it's this. I think the overarching point is, the kind of things that we do to reduce mismatches between expectations of writers and expectations of writers about the meaning of their program actually allows, it creates a space for malicious writers to create mismatch between readers' expectations of their programs, right?
This is super cool. Give me another example. This is great trivia.
All right. And so going back to C, this is a true piece of trivia. People who followed the development of the C language standard over a couple decades will probably get this one really quickly, and it's not relevant to anyone who hasn't. So this is in the trivial in the sense that this program does exactly what you would expect if you're using any modern C compiler. But if you were to run GCC with -stud equals C90, saying, I want compatibility with the 1990 version of the C language specification, what would you Jas, let me open this up. What would you expect this program to do?
I mean, as an expert
now that I've already told you
user,
that it's sneaky, yeah.
Yeah, as an expert C user, I would eyeball this and be like, well, it's going to print out WYSIWYG, and then, like question exclamation mark.
Yeah,
which I believe the correct pronunciation for is.
Yeah. So for people who are listening, pound include less than stdio.h, greater than, and then we've got a main function, and it just does a printf double quotes %s/n double quotes, and then the argument to the %s is the quoted string WYSIWYG ? Bang, right? What you see is what you get, and in TerraBang, but what the actual behavior in C90 and before is, you get it prints WYSIWYG followed by the pipe character.
Wait, huh?
And remember, C is an old language, and programming language designers will bend over backwards to make it easier to write programs in their language, because that's how you get programmers to use your language. And also because it's kind of nice thing to do, to make your tools easier to use. But it turns out that when C was a young language, lots of people wanted to write C using keyboards that did not have certain characters on them, things like the pipe character. And so the solution the C preprocessor people came up with was trigrams, groups of 3 characters that are on C programmers' keyboards that, seen as a unit, are turned into characters that aren't. And so the trigram ? Bang gets turned by the C preprocessor, regardless of whether it's inside a string or outside a string. Because again, this is happening before we found token boundaries. Same as in the Java example.
Same as in the Java case, exactly.
Yeah. This is pre-lexing, pre-breaking things into tokens transformations. So the ? Bang gets turned into a pipe character.
This this feels familiar in the sense that because the compiler is doing this in passes, it doesn't have enough context which the human mind would have when it was parsing it. And of course, as a result, it's going to make a different set of choices.
We've got all this, mental machinery to, consider many possible meanings at once, reject all the ones that are the kind of like, no human would ever do this. And so we reject all those conclusions. But if you're sneaky, you can find one of those interpretations that are just thrown away by our minds subconsciously, and yet, and embed your dirty tricks in it.
So this suggests that there's a whole bunch of there's a lot of space for us for a malicious but trusted developer to use Scott Craver's words, to in an underhanded way get code past the code reviewer. But one of the things that we've said so far is that, hey, if we had better linters, if we had better IDEs, if an IDE integrates tightly with the compiler, the IDE or the linter sees exactly what the compiler is going to do, and heuristically can alert the user, hey, this is unusual. Like, don't necessarily block it, but like, this is kind of odd, right? Like, ASI automatic
semicolon insertion
in JavaScript is known to be problematic, right? Like Douglas Crockett has strong opinions on
when he has opinions, they're strong.
They're exactly right, which is like, oh, ASI was probably a mistake. We should insert semicolons into every place that we intend a semicolon to be. He still has this problem where if we definitely did not intend a semicolon to be inserted, you need to reformat your code. Like return statements are particularly exciting because
restricted productions for people who want to read the spec.
Restricted productions, exactly. But okay, so syntax is hard, I understand, but like other places where we can insert this kind of confusion, and I'm asking that as a leading question because I definitely know the answer is yes. I definitely know the answer is yes. There's a whole lot of other places where we can insert the Trojan source kind of problems, but we need to be a little bit more careful because unlike the Unicode, unlike the source code set, they're not scattered across all of many different languages. They are very specific to individual languages.
Yeah, and I think the reason why I did 3 languages instead, with 3 different techniques was partly because it makes trivia time more fun, but also because these the exact kind of transformations in the history of the language and how it developed and causes each language to do these a little bit differently. And so the token the Trojan source paper is interesting in that this technique does affect a large group of languages.
Right, and I mean, like most people when they think of polyglots, they think of you're
polyglot,
writing the same...
a program that a source file, a language as a language is a set of strings. That does not mean that every string is only in one language, right?
Right, exactly.
And
like
so,
the same string can be interpreted by 2 different programs. In the original polyglot contests, you would want each one of these strings to produce the same output, but you can also do things where you can tease it out so that this string, when interpreted by one interpreter, produces one output, maybe the name of the language that it's run in, and then when interpreted by a different interpreter, produces a different thing. What that means for in the context of our conversation today is that there's a set of strings which, if somebody was just eyeballing a language, eyeballing a file, they may assume that, oh, this is a JavaScript file, or this is a TypeScript file, and
especially if it starts with a especially if it starts with a comment that says this is a Java file. This Java file does such and such.
Correct, right? And so
going back to misdirection and
right. The TypeScript JavaScript is an excellent example. There's a reason why I pushed us in that direction. It's because I submitted a bug to the TypeScript project, not seriously, just as a joke. I tried to get it in time for April Fools, but I failed. Where the same file, TypeScript claims, and is mostly true, that that TypeScript is a superset of JavaScript.
And maybe in the technical set of strings sense, that's true, but not in the kind of, a string in JavaScript has certain semantics.
Right. So this is the part, right? Like, so it is the case, as far as I can tell, that every valid JavaScript program is a valid TypeScript program. I believe that to be true. But implied in that superset statement is that every JavaScript program is a semantically equivalent one to the TypeScript to the TypeScript interpreter interpreting this.
And, you wouldn't want alert 1 in JavaScript to bathe your cat, right?
Right. Which I think by chapter 16 exemptions, it is allowed to do. But
Sorry,
you know, it
that's a
turns
PC39 nerd out right there.
No, yeah, that's right. But you know, it turns out there is a sequence of tokens, you know, which I outline, where you know you can use subtle differences between how each of these interpreters interpret it, you know, to sort of really pull apart what a TypeScript interpretation of a set of strings is going to do versus a JavaScript set of versus a JavaScript interpreter. And again, going back to the conversation around Trojan Source, when you are code reviewing code, like look at your C code. If you received just the blob of code that you showed in this particular slide, if you did not know that sometime later somebody was going to say, hey, I want GCC to be compatible with C90, like there's no way for you to know as a code reviewer that, you know, the semantics of this code is going to change, right? Like you absolutely need a tool that says, I'm looking over everything, not just the diff that you are showing me, and make sure that, you know,
you're kind of limiting your potential reviewer pool if your potential reviewer pool has to understand the history of the language, you know,
like,
since
I mean,
its inception,
since the
right?
beginning of time, right? And you know, I mean, I've spent
and if C time, of course, begins in 1900, you know, January 1st, right?
Is it in 1917? I could be wrong. It's certainly
that's
before
that's the beginning of the Java epoch. I think in C the beginning of the epoch is undefined.
Oh, is that right? Oh, even better. And similarly in these cases, right? Like, you know, you can slide all kinds of confusion in between syntactical differences, between tokenization differences, between AST differences, between differences in the semantics of a language.
He goes to the bookshelf for the listeners.
I'm going to plug my
surreptitious software. I wasn't joking earlier when I said that you wrote a book on how to write.
That's right. There is a program on voting, which you know I was extremely proud of. I'm going to put up the reference here where differences. So the Java language has a, you know, we know the Java language. We understand what byte means, what integer means, what strings mean. And the JVM also understands these differences between each one of these different types. But it turns out, you know, the JVM will do method dispatch by upgrading a byte to a longer object.
It's a numeric type promotion for people who are looking in the spec, yeah.
And that means that there would be lines of code inside your function that say, you know, if a byte is larger, if a byte equals 258, let's say. If a byte equals 258, then do crazy random bad thing. Now, as a code reviewer, you may look this over and be like, well, I can see that this method takes a byte. A byte cannot be longer than 255. Therefore, I know that this bad line of code is never going to execute. Now, I'm oversimplifying here how obvious a sneaky, underhanded developer might be. But as a code reviewer, you may decide that like, oh, this piece of code is completely fine. But unfortunately, the language semantics are different from the semantics of the JVM as it runs. And as a result, it is possible to call this method with a function that causes this thing to be true. And, you know, there's a variety of these. So, you know, I covered token, syntax, ASTs, but like even language semantics, runtime semantics also can cause a developer to be led astray. And unlike, so far we've been suggesting that like, hey, relying on humans to do this is a mistake. We should rely on tooling. But even relying on linters and static analyzers might not be quite enough, because languages may embed all kinds of traps.
And I think the humans are good at short amounts of focus, and but then when you have to do something over and over and over again, like keep an eye out for bears, like maybe somebody tells you keep an eye out for bears, and for the first hour you're like, why would they tell me to keep an eye out for bears if there weren't bears around? And so you're looking around and you're doing a super good job keeping an eye out for bears. The second hour, I'm gonna be like, they're probably pulling my leg, like, yeah, kind of, maybe I'll take a nap, check around every hour or so, check around every 10, 15 minutes, maybe look around for bears. Second weekend, I've got a side hustle.
That's right. And the third weekend, you get eaten by a bear.
Yeah, if I last that long. But the point is, expecting code review to find, expecting code reviewers to be suspicious of each other is just not how we're wired. You work with somebody for months, and one day they decide, I'm going to try and sneak some malicious code in. If they know any kind of underhanded tech, they can probably sneak it in a much larger commit.
Yeah, that's right.
Because we're and so
like not trying anything sneaky, just like standard code.
Yeah, like but I think what you also did in your book was you showed an example where you might, here's a system with strong security requirements. How could I, as a malicious actor, insert something that and then be able to plausibly deny that it was intentional and say, hey,
right.
this is a common Java bug.
Right.
And I think the number of mismatches, the number of the myriad opportunities for mismatches between intended semantics and inferred semantics, as from reading, and actual semantics, the number of layers at which that can happen, like code review is good for many things, but if you're expecting your programmers to kind of effectively keep an eye on each other, I don't think code review is a sufficient tool for that.
So I mean, before we definitely want to keep time for the good thing, bad thing, but before we jump to that, like we should at least give some suggestion of hope, right? Like, so we've suggested a whole bunch of ways in which failure can occur.
Yeah.
Should we trust each other as developers? Is that where like should we set up processes where developers can trust each other? Is that where the boundary is? Do we need to go like where should our security boundary be?
So I think one of the things that should give us hope is that if you've worked with somebody and you have a personal relationship with somebody, their threshold for stabbing you in the back, kind of like inserting malicious code and leaving you holding the bag when management comes and was like, why did you notice this? Like, there are exceptions. The Linux kernel mailing list recently, right? There was that big kerfuffle where some researchers, kind of in contravention of human studies guidelines, actually, they crafted malicious commits to kind of test how much do the Linux kernel maintainers, how much do their processes catch malicious stuff. and then they allow them to go all the way in.
Right.
And, yeah, don't do that. But most people won't do that, right?
Right.
And in that case, the researchers saw themselves as one group. We're here kind of trying to point out problems, and I'm trying to put a charitable spin on it. And they didn't see themselves as team members of the maintainers. If you work side by side with somebody, they're probably not going to screw you over. And so I think just, like there are, yeah, it's easy to fool humans, but, if you've been working with somebody closely, and you haven't given them cause to screw you over, you could pretty much rely on them to just be a decent person, right?
I forget the quote
and
now.
Leave it up to organizational measures. Like if
right,
somebody wants to screw over the organization,
will respond.
They've got ways to, like if the organization wants to identify internal threats, I think is the term for this in security communities. So internal threats measures, kind of those are, and a lot of this comes from the intelligence community, like we need to downgrade somebody's access to confidential information if, they've got a gambling problem, or, they've taken out like risky loans and that kind of stuff. So, like large organizations, they have measures in place for internal threats to identify them and mitigate them. It's not my job to worry about whether the person sitting next to me is an internal threat.
Yeah, I'm going to butcher this quote entirely. I should look this up because in my head, it's a quote that I repeat every once in a while, exactly contradicting the very aspirational outlook that you laid out, which was, I want to say it's Ashley Brilliant, but I could be entirely wrong. I can imagine a world, I can imagine a group of, let me try that again. I can imagine a society that is very peaceful and welcoming and abundant. I can imagine them, and I can imagine us taking over because they would never see it coming, or something along those lines. And yeah. Like I completely agree with you. I think that experimenting in the way that that those researchers experimented on the Linux kernel folk was unethical.
But we also shouldn't minimize that, there are software security supply chain threats, and that they have been open source maintainers. And, open source maintainers have in good faith said, I don't have the time because I need to make a living to maintain this widely used piece of, this widely used open source project. And somebody contacted me out of the blue and they're willing to do that.
To help.
Yeah.
Like they're offered to do work, right? Like,
yeah.
I mean, why wouldn't you let them?
And it's perfectly reasonable to say, this is how the open source community works. Like, somebody runs out of time to do something, somebody else steps up and takes over. And that's, the open source ecosystem at its best. But, like, yeah, the person sitting next to you, or, who you're always on Slack with, in a remote workplace, that person may not stab you in the back, but, random person from the internet
may. In economics, there is a difference between an iterated game and a one-off one, right? When you have a relationship with someone, when you work with someone, when you're in an organization with someone, it is much closer to an iterated game, which means that you still have a threat, but the outcome better be like they pay out for defecting has to be much larger before it is.
And an iterated game is one where, like, you have to choose: do I do something bad to someone, and that affects how they interact with me in future iterations of the game, you know, or do I stay, you know, do I maintain my trustworthiness? And then, you know, so a lot of these kind of, you know, optimal game strategies are do one thing for 0 through n-1, and then an iteration n, like, you know,
just
like
go all
just,
like
yeah,
just blow out your. It's a conversation for a different day. But you know, one of the one of the edge cases around cryonics and death is that, you know, this is the fun way to end this podcast, right? Is to talk about death.
it's a good thing, bad thing, death.
Death, good thing, bad thing. But like, you know, you can accumulate a large amount of goodwill, and you know, if you know that you're going to, you know, if death is coming, like, is that the time to be? Is that the final end? That's when you go all out and capitalize on all of this goodwill that you've accumulated. And the only mitigation that I see around that has always been, sure, you can, but for what joy, right? Like, so, you know, you're about to end as well.
So religious belief as a mechanism for preventing iterated end games.
Good thing, bad thing. When I was in primary school, I read this book. It was called Good Thing, Bad Thing. It was fantastic. It was a character that would, on every other page, this is a book aimed at like 4-year-olds or 5-year-olds. I read it as a teenager and I was fascinated by it, which says something more about me than anybody else. And every other page, you know, the character would get into a good situation and then a bad situation. He would be on a plane, it's a good thing. He fell out of a plane, it's a bad thing.
No.
He's falling onto the ground, it's a bad thing. There's a haystack, it's a good thing. There's a fork in the haystack. Okay, you know what I mean.
I hate roller coasters, but I love me a good emotional roller coaster.
That's right. The worst thing is I've never been able to find this book again, and I don't remember how it ends, which is perfect for, you know, a lifetime's worth of worry. So here's what I'm going to do. I'm going to shoot out one sentence options. And Mike, you get to say whether you think that this is a good thing or a bad thing. What do you think?
So decisive, poorly considered opinions. I can do that.
Perfect. Confusing your fellow developers.
For fun, good. For profit, probably not so good.
So here's the that was a pithy one sentence answer. Here's why you should reconsider. Every once in a while, you want to like keep your fellow developers on their toes. You're not intending to commit it. So, you just want to experiment on them.
So you're going to dress up in the bear suit when I'm like, you know, kind of, I'm sitting there looking for the bear, right?
Yeah, probably a bad thing, right?
Yeah. I think, you know, that kind of stuff erodes trust and kind of, you know, it's, you know, like the subtext there is like, you know, that it's hard to read this. You're where the subtext there is, we're not peers. I am overseeing you. Unless it goes, I mean, if you have, I can understand maybe in some like, you know, kind of organization, the culture is that everybody pranks everybody else and it's kind of taken as lighthearted, but you got to be careful.
You got to be careful. I agree.
Yeah.
Removing potential sources of human confusion from the programming language grammar.
I guess Lisps take this to the extreme, and I like Lisps even though I don't really work with them.
Wait, in which extreme does it take it?
So you know, Lisp, you've got, you know, Lisps, you know, you've got parentheses and you've got terms and you've got quoted, you know, quotations and you've got comments and white space and that kind of stuff, but you don't have like all kinds of infix operators and postfix and prefix operators and difference between statements and expressions and, you know, complex literal syntaxes, right? It's basically just, you know, the grammar is very simple.
It's an AST serialized.
Yeah, I mean, you know, and that's like part of homoiconicity, right? You know, your data, you use the same tools to build bundles of data that you do to represent a program, right? And to some degree, you can, start with one and go to the other, right?
Right.
And transition between the two views. And so, yeah, I think, I think if you start with Lisps, then they're very natural, and many people do. But we're not going to, I think one thing that the Ruby language has shown me is that you can attract a very large, dedicated programmer community by consistently making trade-offs to make it easier on those developers. And Ruby has a quite complicated grammar, but for humans, it actually meshes very well with how very great many people think. And so I think, where I would like to see the focus is less on, simplicity of the grammar, but more kind of how easy is it to craft tools like linters that have the same view of a program as, a linter is necessarily less complicated than a compiler, right? How easy is it to make tools less complicated than the compiler that have an accurate representation of the program, so that you can, kind of do heuristic stuff like, is this likely to cause confusion, and embed knowledge about what confuses people in, like linter rules, yeah, and tools that can run, on, like tools that can run and give information inside code reviews and help reviewers.
Unicode in source code. Given our entire discussion,
I think it's necessary. Yeah, I mean, I think anything that helps non-native English speakers become computer scientists is a good. And yeah, I think
such a large amount of domain knowledge missing.
Yeah.
If this is a small subset of the world that we target. Escapes outside of strings.
I mean, I think I think they're fine. I just, the way Java does it but before you identify token boundaries, allows you to confuse token boundaries. And that's, but, if you want to have escape sequences and identifiers for, ASCII compatibility, I think that's fine.
I have to tell you, the first time, so I've messed up escaping in JavaScript parsers multiple times now with serious consequences. Let's go with that. Because because of context sensitive keywords.
I thought it was not the case that the case now that whether something was interpreted as a keyword depends on whether a character is escaped or not.
That may be true now. It certainly was. I'm talking quite some time ago, and it was definitely the case that I repeatedly messed up, and would always go back to trying to read the spec, and how escaping is done in JavaScript is kind of, at least in my mind, scattered across the spec. Maybe this is cleaned up. I haven't kept up with that, but at that point, I appreciated Java's approach, which was stop everything. First, we do all of the unescaping, then we're going to do this other thing, which was advantageous. But I think that the opportunity for misdirecting the user is considerably larger as a result.
And actually, it that the inability to, for example, have /u0022 inside a string bit some I maintain a few like SecEng projects, and so people test out fuzzers on them, right? To try to find bugs, kind of like, if you want a property-based test my stuff, awesome. And they were generating Java proofs of concept of things, and that actually bit them.
It bit them.
Yeah, and so it's not just a problem for code reviewers. It's
Right.
actually a problem for code generator writers.
Correct.
So yeah.
Right. Magical misdirection on a first date.
I mean, I think if you're going to start a long-term relationship with someone, it helps to like lie to them and build rapport, right?
I was going with, of course, as a child, I was an amateur magician. I was going with like magical misdirection of that kind.
Okay. No,
I'm gonna take your answer.
If that's what you do on a first date, that's fine.
Yeah, mostly first dates, rarely second dates.
Yeah.
Great talking to you, Mike. This was a great topic. I really enjoyed this particular conversation. I got to show off my book, which is, always great. You should go out and buy it. Christmas is coming. I need to feed myself. Yeah, I think that there's a lot more on the UX of programming languages that is going to come out over the next couple of years. I think that this is a topic that people have harped on about for a long period of time, but it feels riper now than ever before that people are paying attention to this kind of thing.
And I think that kind of focusing on one element of the tool ecosystem is kind of narrow-sighted. And going back to the only Perl can parse Perl. Why is that a problem? Because then you can't get this rich tool ecosystem, like linters that identify likely, semantic
problem areas,
kind of interpretation of that.
Sounds great. It's great seeing you guys all. We'll see you same time, same place next week. Chat with you later.
What's our topic, Mike? For today, Mike? Sorry. I am the worst. Jas is like, I nailed it. And then I'm like, I don't even know who I am. All right.
Shall we do it one more time?